the binomial distribution. So there are identical trials. It's already fixed in advance, and you set that number. Each trial has two possible outcomes, a success or a failure. The probability of success on each trial is P, and the failure is 1 minus P, which we'll label Q. In order to be binomial distribution, the trials must be independent. That means one does not affect the other. So if we're using a deck of cards, it requires replacement. If we're using a bag of any sort, it requires replacement. And we're going to let our random variable be y in this case. You can use any letter, but I just happen to use y. So some definitions that we need to look at before we get into this is a reminder on how to do combinations. We just learned this in our probability section, but just in case you forget, we'll do the number of ways that you can choose n items out of k as n choose k. Now there's not supposed to be a line here. It's just supposed to be nk, but I cannot get Google to do that for me. So just remember there's not a line here. It's just n choose k. A binomial distribution's equation is the number of combinations times the probability of success times the probability of failures. Now the formula is a little different in the exponents if you look at it. This is the number of successes, and this is the number of all of your outcomes minus the number of successes. So it just means the number of failures. The expected value can be found by multiplying the number of outcomes times P. Sometimes you'll see a probability distribution written like this, where X is a variable, B means binomial, and then you'll have the number of items and the probability of success here. A variance is a weighted average, so it's N times P times Q, so the number of items times the probability of success times the probability of failure, and then the standard deviation can be found by finding the square root of the variance. So let's jump into some examples. A 6-sided die is rolled 12 times. What's the probability of rolling a 4 5 times? We're going to assume some stuff because I left it out of this problem. We're going to assume that it is a fair-sided dice, so that means it's not weighted, and the probability of success of getting anything is 1/6 because there's 6 sides. So we could write this as X is binomial distribution of 12, because that's number of times we've rolled it, and the probability of success is 1/6. You could write that as a decimal or a fraction, it doesn't matter. So I could have given you this information or this information here, and it says the same thing. Now we have to figure out what the probability of rolling a 4 5 times is. So just for visual purposes, we have 1, 2, 3, 4, 5, and we want each one of these rolls to be 4. So each one of these has a probability of 1/6. 5 times rolling a 4 5 times. Okay. What we really want to do here is use the formula. So the probability of our outcome, here I'm just going to write it down. Hang on. Okay, here's our formula. So we're looking for the probability of 5 times. Oh, I see what I did. Okay, so we want these 5 to be a 4, but there's not only 5, there's 12. So 6, 7, 8, 9, 10, 11, 12. We don't know where our 4s come up, but there are 12 total rolls. Okay, so we're looking for the probability that we get 5 fours. So we're looking for the probability of 5. That means we have 12 items, and we're going to choose 5 of them. And we can put this in the calculator. We're going to get a number from it. You could use the formula for the n factorial formula if you wanted to, but you don't have to do all that work. Now, the probability of success comes next. So that's 1/6. And there are 5 of them. So if you look at my picture, we'll multiply 1/6 times itself 5 times to get this probability. But then we have to also deal with the others that are not 4s. So they have a probability of 5/6 to be anything else but a 4, because the whole probability is 1, the probability of a 4 is 1/6, so Q is 5/6. Now, the power on this is the number of outcomes minus the ones that we want. So 12 minus 5 in this case is 7 other spaces left. So 1, 2, 3, 4, 5, 6, 7. Each of these have a 5/6 probability of not being a 4. So that's what we just found out. So you could draw the picture out like this, but what we've done is combined all of that into equation. So there are 5 1/6 and there are 7 5/6, and we already know by the multiplication rule that we're just going to multiply those out. But then we have to multiply it by the combination number so we can see how many different ways I can put these 4s on here. So that's what we're doing. So it's not just multiplying the probability as an AND situation here, but you also have to multiply by the different number of combinations. Now, you can put this in your Inspire, or you can do it in Excel. I went ahead and grabbed my Inspire so I can do it really quickly because it's just going to be a number. So we're doing a combination, so make sure to use the choose, but we're going to go menu, probability, combinations, and then we want, I forgot, 12, choose 5, so just do 12, comma 5. Again, you can do that in Excel. I showed you that on the last video. So we're going to multiply 792 times 1/6 to the power of 5 times 5/6 to the power of 7. Ooh, you see the crazy math I just did? I accidentally left it in my exponent. There we go. Times 5/6 to the power of 7, and we get, that's a crazy number. I'm sorry, just a second. The struggle bus is real, people. The struggle bus is real. Okay, 792. I was trying to be too fancy. I'm going to put a decimal in here so I don't have to do that again. Okay, so there's my answer. This is the probability, 0.028. So 3 decimal places, or if you're going to put it as a percent, go ahead and move your decimal to get 2.8% chance of getting 4 5s when rolling 12 times. Okay, so we're still using the multiplication rule where we multiply each outcome, but we've come up with a better way to use it by writing the formula for it. So we're going to try another one here. A multiple choice test contains 20 questions with answer choices A, B, C, D. Only one answer choice to each question represents the correct answer. Find the probability that a student will answer exactly 6 questions correctly if he makes random guesses on all 20 questions. So just like before, I have 20 spots available. Each one of those spots needs to be filled up with a probability because it's either he got it right or he got it wrong. So if we were going to rewrite this as a probability, binomial distribution, just so we're getting the hang of it in case you have to do it, is this is a binomial with 20 items, and the outcome of success is 0.25. Now, they didn't tell us that information, right? But if you only have 4 choices, the probability that you pick the correct one is P is equal to 0.25. That means Q, there are 3 outcomes, 0.75, that are incorrect. Okay, so we're looking for the probability that given 20 questions, we get 6 questions right. So that's a 20 choose 6. Our right problems, 25% that it's right, there are 6 of them. 75% that it's wrong, and there are 14 of them. That's 20 minus 6 to give us 14. And from there, we plug that into our calculator. So this is the P of 6 is what I actually meant to write here, probability of 6. 20 choose 6, I did this for you this time, is 38,760 possibilities to get 6 right on the test, because there's 20 questions. So that's, you can get number 2 right and number 4 right, or you can get number 1 right and number 3 right, and those are different outcomes. So there's 38,000 outcomes. 0.25 times the power of 6, 0.75 to the power of 14. When we put that in our calculator, we get 0.169, which is 16.9% probability that he gets 6 out of 20 questions right just by making a random guess on all 20 questions. Okay, so again, I just have a bunch more examples. If you need it, great. Keep watching. If you don't need it, just fast forward to when you do need it. You might need to see me do these yellow ones, just because I know that they're on your homework, problems just like it. But if not, that's fine too. Airplane engines. Each engine of 4 on an airplane fails 11% of the time. Assume this problem obeys conditions of a binomial experiment. So those conditions we were talking about were the ones at the front in the box here. So we're assuming that each identical trial, there are 4 trials. They're independent. If one fails, the other one doesn't fail, and all that fun stuff. So what did we learn here? We know that the number of engines is 4. We know the probability success, in this case, it's not success, but it's fails, but it's not the fails that you're thinking. So the probability that we have a defective engine is what we're looking at as success, 0.11. That means the probability that the engine is just fine is 100% minus the 11%, which is 0.89%. Okay. So we want to know what's the chance that at least 2 engines fail. So that's the probability. If it says at least, that means it could be 2, or it could be 3, or it could be 4. So we'd have to find the probability of each one of those. And did you hear that I said or a couple of times? That means we're going to find each one of those probabilities and then add them up together. So we need the probability of 2 plus the probability of 3 plus the probability of 4. The probability of 2 is, well, there's 4, we're going to choose 2, multiplied times the failures, well, the probability of it failing, so that's 2 of them. That means 2 of them are not failing. Okay, then we'll do 4 choose 3 to find the probability of 3. So in that case, we have a power of 3 on this one and a power of 1 on this one. And then the probability that 4 fail is 4 choose 4. All of them fail. We're falling out of the air. That's scary, okay? we go. So we can put all those numbers together. The probability that 2 fail is... Ooh, okay, I went ahead and put all 3 of those in my calculator. It's getting a little difficult to see. So I did it all at the same time. You could do it as one whole line, and then we're going to go and add them all up. So we want to add up, well, maybe, probability of that one plus the probability of this plus the probability of this. Okay, and we have a probability altogether when you add them up 0.0624, which gives us a 6.2% probability that at least 2 fail.